Alright, today on page 97, we're going to explain trig relationships. So there's a relationship between sine, cosine, and tangent that I want to draw your attention to. And it would be easier for you to see that pattern if you had to go old school like I did, where we had to use the chart to find those trig values. But since you guys use the calculator, you're not seeing them right away. So our objective on page, what did I say, 97? Our objective is to explain trig ratios. Okay, and I'm going to help you see these relationships, or explain trig relationships. I'm going to help you see these relationships by making a little chart. So my chart is going to have sine, cosine, and tangent. And I'm going to use those angles from my special right triangles because they're really the easiest ones to look at. So I'm going to use 0, I'm going to use 30, 45, 60, and 90. Now 0 and 90 we haven't talked about yet, but I'll show you what those are in a minute, okay? So if I were to look at the special right triangle of 45, 45, 90. Okay, this is my adjacent side, my hypotenuse, and my opposite side. And remember, we decided to use radical 2, 2 for this. Okay, if I wanted to find the sine of 45 degrees in this triangle, I'd use opposite over hypotenuse, or radical 2 over 2. So the sine of 45 is radical 2 over 2. If I wanted to find the cosine of 45, well, that would be adjacent over hypotenuse. That would be radical 2 over 2 as well. Okay. And if I wanted to find the tangent of 45, that would be opposite over adjacent, which is radical 2 over radical 2. Now, anything divided by itself is actually 1. Okay, so radical 2 divided by 2 is 1, so the tangent of 45 is really 1. Okay. So now let's look at that 30, 60, 90 right triangle. I'm going to start with my reference angle being 30. This is my adjacent side, this is my hypotenuse, this is my opposite side. Across from the 30 degree angle is 1. The hypotenuse is always 2, and this angle will be this adjacent side will be radical 3. So, if in this triangle I wanted to find the sine of 30, that would be opposite over hypotenuse, which would be 1/2. The cosine of 30 would be radical 3 over 2, adjacent over hypotenuse. And the tangent of 30 would be opposite over adjacent, or 1 over radical 3. And I need to rationalize this. So 1 over radical 3 times radical 3 over 3 is radical 3 over 3. So that's the tangent of 30. So I'm going to fill in these values for 30. So 1/2 radical 3 over 2 and radical 3 over 3. Okay. If I want to do the same thing but use 60 as my reference angle, okay, so you guys can see everything that I did. Use 60 as my reference angle. Okay, my hypotenuse is always 2. Across from 60 is radical 3. Across from that 30 degree angle, which would be up here, is 1. And I'm going to label my hypotenuse. My opposite side is radical 3. My adjacent side is 1. So the sine of 60 is opposite over hypotenuse, or radical 3 over 2. The cosine of 60 is adjacent over hypotenuse, or 1/2. And the tangent of 60 is going to be opposite over adjacent, which is radical 3 over 1. Okay. So I'm going to go ahead and fill these in for sine, cosine, and tangent. Okay. Now, coming up with 0 and 90 is a little bit harder. Okay? Zeros and 90s, we can't really use those as reference angles, but they do have sine and cosine values, and here's why. Okay? We're going to talk about something called the unit circle. Okay? And this is where things get a little amazing. Okay? So let's say this is 1, and and 1. Okay? So let's say that's where 1 is. Okay. If I were to put a right triangle on here, okay, with a hypotenuse of length 1, now let's say this first right triangle that I make is a 30, 60, 90 right triangle. Okay? So, if the angle here is 30 degrees, hold on, I need to do something real quick to help myself make this triangle right. What you're going to do is we are making a circle, or we will end up making a circle, and it's going to help us draw our triangles, and I'll show you the circle in a minute, but let's just draw a little circle centered at the origin with a radius of 1 here. And it's going to help me make this the right way. Okay, so my hypotenusi of all my triangles are going to have, they're all going to have a hypotenuse of 1. Okay, so the first triangle, you're going to go up 2.5 and then go over. And I'll tell you why in a minute. You'll see why in a minute. And this right triangle that's going to be right here inside the circle is going to have 30 degrees. Okay? So I know that the hypotenuse of this right triangle is 1 because it's on this circle. The hypotenuse ends on that circle. Okay? So if this hypotenuse is 1, okay, the sine of this, the sine of 30 degrees, remember, is 1 over 2. Okay? So if I wanted to find this length right here, I'd do the sine of 30 equals O over H. I know from my chart that the sine of 30 is 1/2, and it's actually always going to be that. So I know that 1/2 equals x value over 1. Okay, so 1 equals 2x. So 1/2 is x. Okay? Actually, I'm going to call it y. Sorry for that, guys. I'm going to call it y. And the reason why I'm going to call it y is because I'm finding this height over here. And this tells me how far up this point is. Okay, so what I'm doing is I'm finding the coordinates for this point right here. And to do that, I'm looking for this y value, how high this line is over here. And to do that, I'd find the sine, because this is the opposite side from 30 degrees, and I'd use the hypotenuse, which I know is 1. Okay? Now I want to go back and find the x value, and the x value is this length from here to here. So I would use the cosine of 30. I know the cosine of 30 from my chart is radical 3 over 2. I'm trying to find the x value, and I know the hypotenuse is 1. When I cross multiply, I get radical 3. Equals 2x, and I just divide both sides by 2, so radical 3 over 2 is x. Okay. And I get this kind of neat thing that goes on, where, well, the x is the cosine value, and the y is the sine value. So let's check and see if this works for a 45-degree angle as well. Okay. So the next triangle we're going to make, I'm going to use, I need a different color. I'll use black. Okay. It's going to be a 45-degree angle. And I know a 45-degree angle is just going to go like just through all these lattice points. Okay. So this angle in here is 45 degrees. Okay. And again, I know my hypotenuse is still 1. And if I wanted to find the height of this point, I'd be finding the y value, or the sine of 45 degrees. Okay, because remember, this side over here is my opposite side. If I want to find that height, that opposite side is going to be used, I'm going to be using sine. Sine of 45 degrees equals O over H. And the sine of 45 degrees, remember, is radical 2 over 2. I don't know my O value or my Y value over 1. And when I solve this, I just get Y equals radical 2 over 2. Okay. And then this X value, that's going to be my adjacent side. Okay, and I know that the cosine of 45 degrees is also radical 2 over 2. And following a similar method, I'd find that x is radical 2 over 2. And what I'm finding as I go through, that because the y is always opposite of my reference angle in the center of the circle here, it always ends up being the sine value of the angle. And the x always ends up being the cosine value. So that's an important thing to notice. Okay, so that's really important. I'm going to write it in red.
Mr. Fuentes, please call B401. Call B401, please, Mr. Fuentes.
And the y is the sine of theta. Okay? So if I had a 0-degree angle, if I had a 0-degree angle, that would go right along the x-axis and end right here, if that triangle would. Okay? So this point over here is 1, 0. And if I follow this pattern where x is the cosine value, I know that the cosine of 0 degrees, that's how I would get this line going out to here, this cosine of 0 degrees is 1. Excuse me. The cosine of 0 degrees is 1. And the sine value is always that y value, so the sine would be 0. Now if I wanted to find these values for 90 degrees, well, a 90-degree angle would end up being just going straight up. Okay? And the point where it terminates at, that would be 0, 1. And if I follow this pattern again, that the cosine of theta is x, that means the cosine of 90 degrees is 0. And the sine, if the sine is the y value, then the sine of 90 degrees is 1. Okay? And that just leaves us with tangent. So how do I find the tangent? Okay? So tangent's a little bit harder to look at, but there is a pattern that we could use to find tangent. Okay? And that's where I'm not going to tell you what tangent is. You don't need to know this here for these two values. You could look in your calculators and do the tangent of 0 and the tangent of 90, and you'll get the answers, but it's just, I want you to be able to find the pattern that makes it happen. And I'll give you a clue. There's something about radical 2 over 2 and radical 2 over 2 and 1 that somehow from radical 2 over 2 and radical 2 over 2 we can get 1. And somehow from 1/2 and radical 3 over 2 I can get radical 3 over 3. And somehow from radical 3 over 2 and 1/2 I can get just radical 3. So if you can come up with the values for 0 and 90 for tangent, that's fine. But what I want us to do right now is, looking at this chart, is just see if you can see any pattern between sine and cosine. Are you noticing anything? If I look, okay, first off, sine of theta kind of goes 0, 1, 2, 3, 1. Well, I know that 1 I could rewrite as radical 4 over 2. And why did I do that? Well, radical 4 is just 2, and 2 divided by 2 is 1. And that kind of makes a really neat pattern of sine. If I just look at sine being 0 over 2, 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. In fact, even if I threw a radical over these guys, radical 1 is still just 1. Right? So it's radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. And the reason why I'm showing you this particular pattern is, A, it's really cool, but also because you need to have these memorized. So this is one way that you can help to memorize it. Okay? So I know that this is really 1, this is really 0, and this is really 1/2. Okay? Another pattern that I'm seeing, and maybe you saw it too, is that cosine is just sine backwards. Okay, so if I'm looking at this chart, I'm realizing that the sine of 0 equals the cosine of 90. And the sine of 30 equals the cosine of 60. And the sine of 45 equals the cosine of 45. And the sine of 60 equals the cosine of 30. And the sine of 90 equals the cosine of 0. So this pattern works all the time. And if we notice, if I add the angles together, 0 plus 90 equals 90. 30 plus 60 equals 90. 45 plus 45 equals 90. 60 plus 30 equals 90. 90 plus 0 equals 90. If I add all these angles together, the ones that are equal to each other for sine and cosine, I get 90 every time. So the pattern that I'm seeing here is that the sine of theta equals the cosine of 90 minus theta every time. And I could write it the other way too. The sine of 90 minus theta equals the cosine of theta. That's where I'm going to leave it. We'll talk more on Monday.